Problem 21. The gear marked A is turned clockwise as shown. Which two boxes will move upwards? These are our options. When gear A moves clockwise, it will make this will move anti-clockwise. When it is moving anti-clockwise, this will move clockwise. So because of this will go up like this. And that means it will lift weight 2. So let's eliminate which are not weight 2. So we eliminate this, and we can determine we eliminate this. Now, second part. Since it's going anti-clockwise, this will go anti-clockwise as well. This will go clockwise, this will go anti-clockwise. So when it is going anti-clockwise like this, so it will move like this and go up. That means it will pick 3. Our option is B is our answer. Problem 22. Martha chose one of the 5 structures below and combined it with the structure on the right. The table shows the number of cubes in each column in the combined structure which seen from above. Which of the 5 structures did Martha choose? These are the 5 structures which she picked. She put it on top of it. This table shows the number of the cubes in each column when seen from above. So we have 3 here, we have 2. So that be possibly this one and this one. And then we have 3 here. That means we need to have 3 on top of it. So let's see. All option has 3. So let's move on further. We have 2 which matches with this. We have 1. Now we need to know what comes in here. So we add 2 plus 1, 3, 3 plus 1, 4. So we need to have 4 structure to be in here. 3 is already been we have considered, so we remove 3. Now it has 1, 2, 3, 4, 5. This could not be our answer. It has 3, we need 4, not 3, we don't need it. 1, 2, 3, 4. Definitely this is our answer, and this is 2. This could not be possible. So our answer is option D. Problem 23. Sonia and Robert are playing a game. They can alternatively take 1, 2, 3, 4 or 5 tiles from a pile of tiles. Whoever takes the last tile or tiles loses. At one point of the game, there are 10 tiles left in the pile and it is Sonia's turn to take some tiles. How many tiles should Sonia leave to Robert to be sure that she will win? Let us understand this problem first. We know that player can alternatively pick 1, 2, 3, 4 or 5 tiles. The person who picks the tiles loses. There are 10 tiles left in the pile. Now it is Sonia's turn. So Sonia has to decide how many tiles she can pick so that she will definitely win. Now let us analyze Sonia's best move. We know that if one tile remains, the player must take it as a loss. So Sonia should not get a chance to pick this tile. If 9, 8, 7, 6, 5, that is 1, 2, 3, 4 and 5 tiles remain, the opponent can take all and force a player to pick this tile. So what it means is that any moves that leaves the opponent with 5 to 9 tiles is a winning move for the current player. So these tiles are the winning tiles. Any player who will start from within this block will be winner for definitely. So Sonia should make her smart move before this 6 tiles. Now analyzing Sonia's best move, let's pick our option A, 9. If she leaves 9 tiles, Then Robert can take this tile, 2 tile, or 1 tile. Then Sonia has to pick this tile or this 2 tiles, and then Robert get this winning block and Sonia will lose. So this is not our option. Let's consider option B8. If Sonia leaves 8 tiles, that means she picks these 2 tiles. Then Robert can pick 1 tile and Sonia can pick this tile, and then Robert will pick here and Sonia will be at loss. So there is no definite route to it. So option B is not our answer. Consider option C, 7. If Sonia leaves 7 tiles, that means she picks this tile. That means Robert has the option to pick 1 tile, 2 tile, or 3 tiles, or 4 or 5. And then Sonia definitely picked this, and Robert has to pick this, and this is lost. So our answer is option C, 7. And considering the 6, this could not be our answer. Problem 24. 4 stakes are placed along a 120-meter track as shown. What is the smallest number of stakes that should be added so that the track is divided into sections of equal length? We need to divide 120 meter. So this is 120 meter into sections of equal length by adding the fewest number of stakes. The section length must be a common divisor of 120 meters. So what is a common divisor? Common divisor is GCD, which is a highest common factor or greatest common divisor. So how do we determine GCD? So we say 24, 30, 66, and we see how we can commonly divide it. So 2, we can commonly divide it. So we say 12, 15, and 33. Now commonly we can divide it using 3. So that comes 4, 5, and 11. And now we cannot divide it. So our common divisor is 6. Now the best choice is to divide the track into 6 meters sections. Now the required stake positions for 6 meter intervals along the 24 meter. 6, 12, 18, and 24. So that makes a equal 6 divided. So 24 divided by 6 gives us 4. So we got 1, 2, 3, and 4. Now again 30 divided by 6 gives us 5. So we need to have a 5 gap in between. So we say 1, 2, 3, 4, and 5. That is 6, 12, 18, 24, and 30. Similarly, 66 divided by 6 gives us 11. That is, we need to have 11 gaps in between. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And this is how it is: 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66. Now let's count all the stakes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Now out of this we have been given 4 already. So we have 1, 2, 3, and 4. So we say 21 minus 4 gives us 17. So we need 17 sticks, which is our option C. Problem 25. Which of the following four shapes has the greatest area? These are our options and these are our shapes. Now let us go step by step as usual. The best part about these shapes is that they are placed on a grid, giving a clear sense of measurement. To determine the area, we can outline a square around this shape using the grid and then divide it into four smaller squares. Now if we observe shape W, we draw a square and then divide it into four small squares. Now looking into this shape, we notice that one of the triangle has the same height and base as this triangle. That means we can reposition this triangle here and fill this area. Similarly, the height and base is same as this base and height. That means we can reposition this here and fill this area. That means we got two filled square. Similarly, let's observe diamond. We draw a square on it. We see this triangle, the green triangle here, has the same height and base, and we can reposition here because it has the same height and base. That means we can fill this green. Similarly, this triangle we can reposition here and we can fill this. So now again we got two small squares. Now let's analyze crown shape. We draw a square. The tip of the triangle is not touching here. If we extend an imaginary line here, that means we have a triangle with same base as this one, this triangle, and this is the height. We can make it half. So this half triangle can be repositioned here. We can fill in here. And again the same, this half triangle we can reposition here and this fill. That means we got two complete squares plus this extra area. So this is more than 2. So that could be our answer. Let us try option E before we conclude. Here we see that the base and height is same as the base and height for this triangle. So we reposition here and we fill this area. Now we have, let's half this triangle. So we see that half of this base and this triangle, we are considering this triangle. So height and the base is same as base and height of this triangle. That means we fill in this area for this. So we move this one. Similarly, we can move here this one because this base is same as this base and height same as this height. So we reposition. So we have this complete area. That means 2. So which has the greatest area? The crown. So our answer is C, the crown. Problem 26. Peter has 2 coins with a number on each side. One of the coins has the number 7 on one side and the other has the number 10 on one side. By tossing the coins and adding the numbers on top of the two coins, he can get 4 different results: 11, 12, 16 and 17. How many different numbers can be on the opposite side of the coin with 7 on the other side? So Peter has two coins, 7 and 10. If he sum, for example, he sums 7 plus 10, he gets 17. If he plus 10 plus some number behind 7, he gets a sum which is out of this. We don't know which one. It could be 11, it could be 12, or it could be 16. If we sum 7 plus some number behind 10, he will get some number out of it. And when these two numbers which are unknown are sum, we will get a sum. So we need to find it out, what are the possible numbers behind 7 which could give us results 11, 12, 16 or 17. So we have two coins, 7 and 10, which is visible up front. So we know we have this sum. So we consider 11, 12 and 16 as the sum. We know the front one, 7 plus 10 is 17. So we are not considering this option. Now let's assume what would be the other side of 7 if the sum is 11. So we consider here 10 plus that number gives us 11. What would be this number? It would be 1. So 10 plus 1 gives us 11. So there is one option we know would be 1. Another option, when the sum is 12, what would be the option? 10 plus 2 gives us 12. So here 10 plus 2 gives us 12. So when it would be 16, 10 plus 6 gives us 16. So these are the possible numbers behind 7 are 1, 2 and 6. Now assume we have some 11, 12, 16 and we have to find a number behind 10. What would we add to 7 so that it becomes 11? We will add 4. 7 plus 4, 11. What we will add 7 so that it will become 12? 5. 7 plus 5 gives us 12. What we will add to 7 so that it becomes 16? 9. So these are the possible combinations that could be behind 10. Now let us verify the possibility. So what is the combinations we can make? 1, 5. If 1 is the number behind 7, then it could be 5 behind 10. Or 1 behind 7, then 9 behind 10. So let's consider one possibility. If 1 is here and 5 is here, it's a correct combination? No, because 1 plus 5 is 6 and we do not have any number which represents this sum. So we take it out 5 with 1 though. Now consider 1 and 9. So we have 1 and 9. 9 behind 10. We know 10 plus 1, 11. 7 plus 9 gives us 16. So we got 16 and 11 here. 7 plus 10, we know 17. And 9 plus 1 gives us 10. And this is, we needed 10, 12. So this is not our answer as well. So 1 could not be possibly behind 7. Now let us consider 2. The combination for 2 will be 4 and 9. It would not be possible to have 2 and 5 behind because both are having with the same sum. So we'll take an alternate combination. So let's consider 2 and 4 combination. 4 plus 2, 6. Here, this is not possible. 2 and 9. 9 plus 2 gives us 11. Good, that's good. We know 7 plus 10 gives us 17. So 11 and 17 we cancel. 10 plus 2 gives us 12. Good. and 7 plus 9 gives us 16. 2 could be our 1 number. Now let us consider options for 6. If 6 is behind, then it could be 4 or 5. So if 6 is behind 7, then let's consider 4 is behind 10. 6 plus 4 gives us 10. There is no sum here, so this is not possible. Now let us consider 5. So if 6 is behind 7, then, and if it is 5 here, let's sum that. So we know this, 7 plus 10, 17. 6 plus 5 gives us 11, and 17 we cancel. 10 plus 6 gives us 16, and 7 plus 5 gives us 12. This covers all our sum. So our possible numbers are 6 and 2 that could be behind 7. So we have 2 numbers. So option is B. Problem 28. In Kangaroo Land, the alphabet used by the inhabitants has only 3 letters, K, G, and R. On the side, we see a crossword in Kangaroo Land language. When completed, it uses 4 of the 5 words. These are the words. Which word is not used? These are our options. So this is a crossword puzzle. The black spots are not being used. The white are where we have placed the crossword. Now look into these words. We have KKG. Let's clear the screen first. So we have KKG and KGK. There is one spot where we will have a common word, this direction. And there is another, RJK and RGG. So let's use first this one. So we used K, K, G. We use K, G, K. Now, is there any word where K can come? No. G can come, we can use either of this. So we can use RGK or RGG. So we have used 3 words, not even 4 words. So this is incorrect. Now let's use this. So we say R, G, K, and R, G, G. Which one has G in between? This is the one. So we use K, J, K. Now, which one has K in center is this one. K, K, G. So our answer is option C. G, R, K is the word which is not used in this crossword puzzle. Problem 29. The teacher wrote on the board the numbers 1 to 15. She split them in 5 groups of 3. The sum of the numbers in each of the first 4 groups was 25, 27, 30, and 31. In which group did she put number 4? These are our options. So first we calculate the total sum of number from 1 to 15. Next we will add the sum of the 4 known sums. Finally, we subtract this total from the full sum, and the difference gives the sum of the 5th group. Now let's find the total sum of all these numbers. So we say 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21, 21 plus 7, 28, 28 plus 8, 36, 36 plus 9, 45, 45 plus 10, 55, 55 plus 11 gives us 66, 66 plus 12 gives us 78, 78 plus 13 gives us 91, 91 plus 14 gives us 105, 105 plus 15 gives us 120. So the total sum is 120. Now let us add the given group sums. So 25 plus 27 gives us 52. 52 plus 30 gives us 82. 82 plus 31 gives us 113. So the sum of this group is 113. Now what is the difference? Difference is 7. So 7 is the fifth group and sum of the group 5 is 7, which means it must contain 3 numbers that add up to 7. The only numbers from 1 to 15 that can do that are 1, 2 and 4. 4 plus 2, 6, 6 plus 1, 7. So our number are 1, 2 and 4. So number 4 is in group 5. So our answer is option E, the fifth. Problem 30. In the multiplication shown, A, B, C, D and E represent different digits. This is our multiplication set. If the multiplication is correct, what is the number that has a value equal to 8? So we have to find out where the value 8 resides. These are our options. So let's start. The multiple of 3 that ends in 1 is 7. So 7 multiplied by 3 gives us 21. So we would say E is 7 and we raise 2 to the next number. So E is 7. So 3 multiplied by 7 gives us 21, gives us raised 2. Now subtract the carryover. 7 minus 2 gives us 5. Now we are looking for a multiple of 3 that ends in 5, which is 3 multiplied by 5 gives us 15. So our D is 5 now. So 3 5s are 15 and we carry 1. Next, 5 minus 1 gives us 4. The multiple of 3 ending in 4 is 3 multiplied by 8. So C becomes 8 and we carry over 2. So 8 3s are 24. We gives 4 and 2. So our C becomes 8 and this is our answer C. Now let us continue solving this. It's very interesting. Now 8 minus 2 gives us 6. A multiple of 3 ending in 6 is 3 multiplied by 2 gives us 6. That means we get 2 here. And 0 carryover, B is 2. Now 2 minus 0, 2. That means we need to find the multiple of 3 which ends with 2, that is 4. So 4 3s are 12, 2 carry 1 and this is our 1. So 4 3s are 12, carry 1. And A is 4. So let's verify if we are correct. So 3 times 1 gives us 3 plus 1 gives us 4. So our answer is 42857, the result of this multiple. However, we knew our answer is C. So we have finished part C of the 2023 Math Kangaroo Challenge for grade 5 and 6 together. You guys have done an amazing job solving these tricky problems. If you really enjoy solving these, please do not forget to subscribe my channel for more math challenges. And make sure to check out next exciting puzzle. Keep up the great work and see you in the next video. Thank you.